GPIO 1.3 Hardware Overview of the Raspberry Pi 4. In this video, we will cover the following topics: hardware specifications of the Raspberry Pi 4, Raspberry Pi 4 board overview, Raspberry Pi 4 pinout diagram overview, serial interfaces on the Raspberry Pi 4. Let us now delve into some of the technical specifications and features of the Raspberry Pi 4 that make it so special. Firstly, the Pi 4 uses a Broadcom BCM2711 SoC along with a 64-bit quad-core ARM Cortex-A72 processor that runs at 1.5 GHz. This chip is the brain of the Raspberry Pi 4 and is the primary reason the Pi 4 has the upper hand in speed and performance compared to its predecessors. But this CPU chip tends to get heated when it is run for a long time. This is why, as mentioned earlier, it is advisable to use a heatsink and fan along with it. Another interesting feature of this SoC is that it has a Broadcom Video Core 6 model for its graphics processing unit, which is a newer and better version of GPU compared to the GPUs used in the earlier versions of the Pi. The Raspberry Pi 4 features the LPDDR4 SD-RAM. As mentioned previously, the Pi 4 comes in 4 different RAM variants: 1GB, 2GB, 4GB, and the latest 8GB, depending on the user's requirements. Higher RAM, along with a fast processor, results in improved performance of the device. Apart from this, the Pi also has a dedicated slot and micro SD card reader for inserting the micro SD card in which the Pi OS is installed and run. Now let us see the various ports on the Pi 4 board. The Raspberry Pi 4 has a USB Type-C port for connecting the power supply unit. It has 2 USB 2.0 and 2 USB 3.0 ports, along with a fully featured USB controller chip for connecting peripherals. The Pi 4 also has a 3.5 mm audio-visual jack. Another feature unique to the Pi 4 is that it has 2 micro HDMI ports, meaning it can support 2 4K displays at the same time. Moving on, there are 2 on-board status LEDs on the Pi 4, a red LED and a green LED. When powered up, if the red LED lights up, it indicates that there is a stable power supply to the Raspberry Pi board. The green LED indicates the status of the micro SD card. It blinks in specific patterns to indicate the different problems that have occurred because of the micro SD card. For example, if it blinks once, it means the micro SD card is not compatible with the board. If it blinks 2 times, it means that the micro SD card cannot be read, and so on. To troubleshoot this, ensure that the micro SD card is mounted properly after the OS is properly installed. Now let us look at the GPIO header pins of the Raspberry Pi 4. The GPIO or General Purpose Input-Output pins on the Raspberry Pi 4 board are used to interface sensors, actuators, and other such modules with the Pi 4 board. There are 40 GPIO pins in the Pi 4. Among these, there are 2 3.3 volts and 2 5-volt power pins and 8 ground pins. Some of the remaining 28 usable GPIO pins also function as pins for UART, SPI, I2C, and PWM, among other interface options. The UART or Universal Asynchronous Receive and Transmit use the transmit and receive pins to connect with peripherals. The SPI or Serial Peripheral Interface requires the clock, master out slave in, and master in slave out pins to establish a master-slave relationship with peripheral devices. The I2C or Inter-Integrated Circuit Protocol use the SDA or data pin and SCL or clock pins to control multiple devices. Along with these functions, 4 GPIO pins are capable of hardware PWM and all the GPIO pins are capable of software PWM. Next, with regard to networking and connectivity, the Pi 4 supports Ethernet, Wi-Fi, and Bluetooth. The Pi 4 board has an Ethernet port and Ethernet controller chip. It offers gigabit Ethernet support as compared to the earlier versions of the Pi that only offered throughput in megabits. Next, the radio module on the Pi 4 offers dual-band 802.11 AC Wi-Fi. This means that the Pi can connect to both 2.4 GHz and 5 GHz Wi-Fi networks. Along with this, the radio module also supports Bluetooth 5.0 and Bluetooth Low Energy. Another interesting feature in the Pi 4 is the camera serial interface port and display interface port. The CSI port uses an industrial-grade interface technology that supports up to 4 GB throughput. This port is directly interfaced to the graphical processing unit. Thus, there is less load on the CPU when processing images or videos. Similarly, the display interface port is also designed such that for CPU-intensive applications, the GPU takes charge of driving the display module. If you wish to learn in further depth about the components of the Raspberry Pi 4 and more about its technical features and aspects, you can refer to the official datasheet of the Raspberry Pi 4 Model B. The link to the datasheet is shared in the resources. Video summary. In this video, we have covered the following topics: hardware specifications of the Raspberry Pi 4, Raspberry Pi 4 board overview, Raspberry Pi 4 pinout diagram overview, serial interfaces on the Raspberry Pi 4. In the next video, we will learn how to install and set up the Raspberry Pi OS.